Our journey takes us directly to the ambitious Scandinavia to Mediterranean Tunnel project. This ambitious venture, although not ancient, takes inspiration in the past, where the first tunnels were born out of the need to reach water. This can be traced back to the ancient Qanat system in Persia, designed in the first millennium BC, which was a brilliant strategy for accessing aquifers and moving water through gently inclined tunnels. The Romans expanded on this idea, building extensive underground passageways for their aqueducts, remnants of which can still be seen today. Moving on to the 19th century, an age defined by the Industrial Revolution and the rapid growth of rail networks. Tunnels played a crucial role in this development, enabling trains to traverse mountains and connect far-off cities. The Mont Cenis tunnel through the Alps, finished in 1871, was a staggering engineering accomplishment that embodied the possibilities of tunneling technology. While marveling at this engineering marvel, it's also important to consider its economic implications. The construction of the Mont Cenis tunnel required significant financial investment. Although the exact estimates remain undisclosed, the project was undoubtedly costly, involving years of hard labor and advanced engineering techniques. The funding came from a variety of sources, including government grants, private investors, and railway companies, all of whom foresaw the future importance of this infrastructure. The economic impact of the tunnel was far-reaching. It not only drastically reduced travel time between cities, but also stimulated trade and commerce, leading to economic growth in the regions connected by the tunnel. The Mont Cenis tunnel, therefore, was not just an engineering marvel, but also a key catalyst for economic development during the Industrial Revolution. As the dawn of the 20th century approached, the focus pivoted from trains to automobiles. The Holland Tunnel, a marvel of engineering, came to life in 1927. Its birth was a result of the mechanically ventilated underwater tunnel built, catering to the burgeoning wave of automobile traffic. This revolutionary construction project was no overnight feat. It took several years of meticulous planning, rigorous design stages, and countless construction phases before it was ready for use. It was an era-defining venture, setting the blueprint for future underwater tunnels. One of the most notable ones being the Channel Tunnel, a landmark project linking England and France. The construction journey of such tunnels typically involves multiple stages, from initial surveying and design to excavation and finally, ventilation installation, each stage completed over a projected timeline spanning years, or even decades in some cases. But the aspiration of human engineering is limitless. Picture a tunnel extending from Scandinavia to the Mediterranean, a distance exceeding 3,000 kilometers. This endeavor would overshadow all previous tunneling undertakings. It entails bypassing an array of geological, technical, and financial hurdles. The technical challenges are monumental, ranging from the design of the tunnel to the construction techniques. The design must withstand varying geological conditions and unforeseen environmental factors for an unprecedented length. For construction, there are questions about the type of that can endure such an extended project, the problem of waste disposal, and the complexity of coordinating an international workforce. However, engineers plan to tackle these obstacles head-on by employing design and construction technologies, using AI-driven algorithms to optimize construction processes, and establishing effective waste management procedures. They also advocate for comprehensive international collaboration to streamline the project across borders. Despite these challenges, the potential rewards are massive. This tunnel could bring a revolution in European transport, enhance connectivity, and may even cut down on carbon emissions by transferring freight from air and road to rail. The strategy would have to be diverse, incorporating both land and undersea tunneling, possibly utilizing technologies such as tunnel boring machines and immersed tube tunnels. This approach would also require the collaboration of several nations, a demonstration of the strength of international cooperation in tackling enormous challenges. Notably, this infrastructure could significantly transform the landscape of global trade and transportation. By providing a more direct route, it could streamline the flow of goods, potentially boosting economic growth across participating countries. Furthermore, with the right planning, this project could also contribute to our ongoing fight against climate change. By shifting a portion of transportation to this method, we could potentially reduce carbon emissions, thereby creating a more sustainable and eco-friendly alternative to conventional shipping methods. In conclusion, the tunnel project that aims to join Scandinavia and the Mediterranean is a daring embodiment of human creativity and ambition. From historic waterways to potential transcontinental corridors, tunnels represent our technical expertise and our unending ambition to challenge limits. The project holds extensive implications, offering a future where geographical barriers and distances become increasingly insignificant. Tunnel is not merely a testament to our ability to modify our world, but also a symbol of the possibilities we could unlock. From economic to environmental benefits, improved connectivity to reduced transportation time, the potential advantages are manifold. As we teeter on the edge of turning this dream into reality, we realize that our underground journey has only just begun, but the rewards it promises are monumental.